Good afternoon, welcome, and buonasera. What a huge title. Yes, remotisation, and is a concept that I think you will find also later on, because the next speaker will speak about remote towers. So it's a concept that now is engaging all the ATM system. And we do more or less the same with our personal concept of remotisation applied to the transfer of the ATS service provision for the approach from a ground environment to the ACC. In March 2018, the ENAV Board of Directors approved the new ENAV business plan for 2018-2022, maintaining the ENAV focus on the ENAV core business activities and in the context of the European regulation, Single European Sky First. The new business plan outlines a new organizational model which is feasible to improve performances, productivity, and competitiveness in a consolidated safety scenario. The key word in this slide is performance, because in the business plan, the concept has been explained as the capability for all the organizational structure of ENAV to respond rapidly to any changing in our stakeholders' demand. And we found this concept all over our business plan. Of course, taking benefit from a flexible organization, from more agile processes between the different functions of ENAV, the business plan outlines, or better, our corporate expectations was to combine together an overall process of professional growth for all the personnel of ENAV involved in the change, together with the feasibility of enhancing a more efficient and detectable way to manage costs and performances of the system. The current outlook of our agency in the operational environment is this. We got 4 ACC that are located in the northern part of Italy, in Roma and Padova, and in the southern part in Padova, in Brindisi and Roma. We manage 45 control towers, so 45 airports. You see 44, you got a new entry. And that's where we focused. Normally, the approach service unit is located in the control tower. And just in the major airport, I mean Roma and Milano, the service is carried out by the ACC of Roma and Milano. In the business plan, we found 2 different areas of intervention. One is the reorganization, the internal reorganization of ENAV, and the most impacting is the reorganization of the operating area. What is in the business plans is a new operating model which consists of 4 main pillars that are the integration of the APP service with the first step, the approach service in the ACC, the migration of 4 ACC into 2 sites. So we will have just at the end of the business plan timeline, we will have 2 ACC. One will be located in Roma and the other one in Milano. The technological and industrial transformation of Padova and Brindisi into the remote tower hubs. So we will concentrate in these 2 sites the management and control of the new world of remote tower, and the centralization of activities of monitoring and maintenance. That's to reduce intervention time and to maximize productivity in this part of the ENAV agency. Okay, well in advance of the content of the business plan, ENAV set up a group, a working group, composed of technicians, engineers, controllers, really heterogeneous. The expectation was to create the model to drive the change and to give support to the content of the business plan in terms of reorganization of the operating area. This working group strategies envisage 3 steps. First of all, the impact on airspace design. The second one was the impact on ATC system modification if needed. And the last one, most impacting one, the validation of the solutions and the training of the personnel involved in the change. Of course, the process was so easy, but the task was you have to do that within the limit of these pillars. First of all, use in-house solutions to reduce cost and to allow an upgrade of internal system. We have just to spend money on what we have. Second pillar is to ensure the replicability of the process. I mean, don't analyze the process in itself, but you must create a model that we may replay for the governance of every changement from the APP to the ATC. Third was to optimize the ATC system modification and integration. Take a look if everything is working, if it works properly for the change. Predict the flexibility. It's a huge goal because we know, we have tested on our skin that airspace organization models are fluctuating. 20 years ago, we spoke about punctuality, aircraft speed, aircraft performances. Now we are speaking about predictability and about cost containment, so a completely different world. Please do not create a process that is not flexible. We can manage different models with the same process. And the last one, I think you will need dedicated supported tools to manage validation and training. Try to build these new tools, to give us reference about these new tools. So each one of us, I am an air traffic controller, so by my side, I put on the table, of the common table, airspace solutions. We started from the airspace design, and you know, in Italy in 2016, we implemented the free route concept. Behind the free route implementation, we have a lot of studies, and we create a lot of solutions, and we validate a lot of scenario. And so we said, why do not use the same approach or more or less the same solution to manage this new task? So the group took with us solutions like free route airspace, dynamic airspace configuration, in the meaning that when we implemented the free route airspace, we envisaged the airspace like a wall, made of a lot of bricks. And so we divided the en route airspace into some little sector to be combined together or decombined, just to let the aircraft flown in the best way, and to balance as much as possible the workload of the air traffic controllers in the different scenarios. That's a good option. We said, okay, we can take it with us to manage the approach migration. By the approach scenario, we took with us solution in design like as a PBN implementation plan to simplify and to standardize the approach, because the main task was to reduce as much as possible the impact on air traffic controller in the transition. That is the traffic in Olbia and Alghero. About 3 years ago, you can see a sort of spaghetti way to manage traffic, and that's a standardized way to manage traffic related to trombones implementation, ENAV.IT solutions in the aerodromes of Olbia and Alghero. Another topic is we have reshaped all the controlled area because we know that main task was to reduce the ATCOS workload in the en route environment. En route controllers are not so used to using to manage VFR traffic. So we try to reduce the impact on VFR traffic in en route working methods. That is a typical solution. That's an aerodrome control zone. That's a control area. We reduce the common line just in one point. So a VFR traffic entry has no need to contact the approach, but may contact directly the tower controller. And so, according to this new reshaping, we established new working methods and a lot of silent procedures to reduce ATCOS workload in terms of coordination. All these solutions are in our pockets to describe the final solution for the approach migration. We spoke about a second step as ATM integration. About 10 years ago, ENAV did a choice to centralize the collection of radar data, telecommunication data, and aeronautical data into 3 main containers, and then to let all the data available all over our sites by means of the ENAV.IT. This solution helps to maximize the data integrity, to minimize the data redundancy because you don't have, to reduce the possibility of cyber attack. You have just to control these 3 sites to control your data, and of course, last but not the least, to minimize the cost, of course, or to reduce the cost. So we got in our pocket free route solution and integration, and we apply together to the approach scenario. We try to define the elementary brick for the approach. That's, that's a Lego brick. It's universal known. And we defined the concept of elementary sector, that is the abstract, smallest and simplest container of radar data, telecommunication supports, aeronautical message, meteorological information, and so on, according to the ATS service to be provided. So that represents not a real sector, but just an abstract concept to say, okay, that's what I need to provide this kind of service in this area. When you put together the concept with the scenario, you have created the operational sector. And to fill the operational sector may be possible you need to put together more than one elementary sector. In this way, we have created the concept of elementary and operational sector. That was the concept for the free route environment. We applied exactly the same for the approach solutions. Now the brick is composed of 3 tanks, where we have what we need to provide approach service, the main containers to pick up the data we need, the airspace design. Here you see the trombones in Olbia that we planned. And when I say airspace design, I mean also working methods and so on, everything that needs for the operational environment to work on this scenario. The minimum number of controllers we need to manage and to provide this kind of sector. And we found with this approach a lot of solutions, a set of feasible solutions. Now we have to choose which one is the better. Next step is to verify with a test the technical integration of the technological set of the transformation, the operational scenario validation, to understand which is the better option among the set we found, and last but not least, the ATCOS training. Remember that about ATCOS training and operational scenario validation, the input from the management was try to find a solution that may help you to reduce costs and time for validation and training. The solution that we found is called EATOMS, ENAV Air Traffic Operation and Management Simulator. That is a training system, not a training tool, a training system, able to provide training, validation of the operational scenario, and ATM system integration and testing all together in the same tool. And using a real scenario. It means that the data that we use in the training system are the real data that we manage every day with the same processor that we have in Italian flight data processor, with the same structure organization that we found for the migration. And this system is founded on the assumption that the training environment should match the working environment as closely as possible to maximize the effect of training. As close we are to the reality, much better the final result will be in terms of training. So you can see that in the training system we got a very realistic navigation model. You can find the feasibility of built scenarios by scratch, importing data from records, from files, from Excel, or directly from Nest modeling tool. The high scalability, which is a concept fashionable in this time. That means that you can customize the training system according to your need. You do not need to oversize your training system if you don't need. It means cost reduction. Fast prototyping means that the system is easily configurable. You may act on the system immediately, and the system reacts to your input. And the system can be integrated with every flight data processing system by using standard protocols. So easy concept, real environment. That's hard to describe, because even if it's not acceptable, it's a matter of fact that the training efficiency is also measured in terms of training cost. It's unacceptable, but it's a matter of fact. So an increase in efficiency may be realized when the same level of training can be provided or can be achieved is better in a less costly system. Here, the scalability of the system helps you to choose which is the better solution and to pay exactly what you need, because you can customize the service or the training according to your needs. The scalability, the flexibility of solution, laptops, mini PCs, that's 15 centimeters per 15 centimeters. It's more than a double of an iPhone. Workstation on server racks, you have just to establish what kind of training you need. Validation and training. We know that air traffic controllers are used to speak in, or prefer to have interaction about concrete, about real scenario, not about abstract concept. So to create a system that is as close as possible to the reality is a must. In this concept, it's important to understand that the consistency between the stimuli you received with the controllers that do not accept abstract concept and the reaction is the key to understand the efficiency of your training. So it's necessary to create a training situation that must be as close as possible to the reality, and the system helps you because it's also able to manage interaction among the actors, executive, planner, supervisor, because you can investigate everything, because you can put the task in the system to be analyzed. And the system is able to manage together the task regarding executive planner, or, for instance, supervisor. Flexibility means the feasibility of the system to be used as demonstrator for the training in itself or for individual training. Demonstration is important because you can create a scenario and you can take with you the scenario to demonstrate to the controller you need in what is the way to manage this situation and to manage what we call generally the continuation training. The second task is for the training in itself. You can configure the system according to your needs. You have just to define if you need the pseudo-pilots, how many positions you need for controllers. So it's flexible, a system. And the last one, we used a lot for Olbia. Because happens, for instance, that when you start training, if you got a lot of persons to be trained, at the end of the process, the first controller you trained never used the training, so maybe is not so confident with the training in itself. To avoid that, we put a laptop in the operation rooms to keep alive in the mind of the controller the training period and to refresh continuously before the implementation of the process. This system is also able to perform software testing, stress testing, and validation, because it may use common formats, asterisk, ADEX, POD, so what is natural, and you can put inside the software you need to test in a real scenario, because all the environment is the real scenario. Okay, by the end, that was our checklist for the process modeling. And by the end, we realized that we have used in our solution, we have updated the solution we had, as for instance, the training system. We have ensured the replicability because we have created the model. We have optimized because we have checked with the testing feasibility of the training system, modification and integration in the ATM system. We predicted the reversibility of the process, and we implemented new automated tools called eAtoms with a partnership with ECNOSky, which is our industrial partner. So I think that the pillar checklist is okay by my point of view. And that's the final result. Our concept of remotisation means we can put in our suitcase eAtoms to provide the training, validation, and testing. A lot of bricks to create the adequate scenario to be managed. And we can put wherever we want. We just need a working suite and to link to the ENAV connection to create, without any logical connection to the geographical location of the site, the feasibility of managing any kind of ATS service wherever we want. What I want to say, just to finish this very, very long presentation, is that that's our idea of remotisation. Remotisation means the feasibility of manage a process without, or better, regardless any geographical limitation with the position of the object. I think that in the way to create the process and to manage the transfer from Olbia to Rome ACC of this ATS service, we did that. So I think we have responded at this requirement of remotisation in the adequate way. Thank you.